Okay, so let's have a look at this AQA Physics A-level question. It's a mechanics question with energy calculations about a roller coaster. So pause the video and read the question if you haven't already. Right, initially we're being asked to find acceleration. We're told something goes from rest to 58 meters per second in 3.5 seconds. Okay, so it's quite straightforward. We're simply doing acceleration equals delta V over t. The change in velocity is 58. The time is 3.5. So we sub the numbers in, calculate, and our calculator will return a result that's 16.571429. So you're not going to write all that down. Now the AQA will check once per paper that you are being sensible in your significant figures. You were given data to 2 significant figures, so you should give your answer to 2 significant figures. If you state it to any higher than that, you're overstating the accuracy to which you can write something. If I write down that the acceleration was this value, I am saying I know to this level of precision, okay? And I clearly don't. So you might get away with 16.6, but actually since it's to 2 significant figures here, you should give your answer to 2 significant figures here. Okay, so the answer is 17 meters per second squared. In fact, sorry, the unit's already given, so we didn't need to write the units again. Right, next step. Calculate the average tension in the cable. You're given the mass. You've just calculated the acceleration. So the force required to accelerate this object, so that's the tension in this cable, would have to be equal to the mass times the acceleration. And the mass is 5800 times the acceleration, which was 17, and that comes out at 98.6 kilonewtons. And to be consistent with our units, I'm going to round that to 2 significant figures, because again, that's to 2 significant figures. This is to 2 significant figures, so it makes sense to write this to 2 significant figures. That's 99 kilonewtons. Sorry, that was times 10 to the 3, I should have mentioned, 10 to the 3. You can see it would be a big number. Right, 99 kilonewtons. Okay. Now, calculate the distance the train moves whilst accelerating from rest to 58 meters per second. Okay, so Suvat question. What values do I know? Suvat. I don't know the distance, it's what I'm trying to find out. I know it started from rest, 0 meters per second. I know its final velocity is 58. I worked out the acceleration to be 17 meters per second squared. And the time is also given to me in the question, and it's 3.5 seconds. So I need to look at my equation sheet and determine which is the best Suvat equation to calculate S. So there's several ways of doing this, but the equation that sticks in my mind, and I never seem to be able to forget, is S is equal to ut plus a half at squared. I can see that I can get rid of u because u is 0, so I'm simply going to do S equals a half of the acceleration, which is 17, times the time squared. Okay, so when I calculate this, I get basically 104 meters. Okay, so that's 104 meters. I got a bit of a bug with my pen here, I think. 104 meters. Okay, so I'm given the unit. I don't need to write it in. Okay, so this is the tough bit of the question. I would imagine this is what probably tricks a lot of people. Calculate the average power input if the system is only 20% efficient. So you've got to imagine that basically all the work done on the carriage that we know about, the useful work that got converted into kinetic energy, is only 20% of what's been put in. So there's 5 times more energy that's been put in than we're seeing, right? So that's kind of the intuition as to how to approach the question. So now, how do you go about doing it? Well, since it's asking about power, it's probably a good idea to look for the formula for power. You should find on your equation sheet that power equals work done divided by time. Really, I would hope you would know that equation. Also, on the equation sheet, the formula for work is force times distance. So force times distance divided by time. So we're going to work out how much power must have been put in. Okay, sorry, how much power the roller coaster has received usefully. So the roller coaster had a force of 99 kilonewtons applied to it, 99 times 10 to the 3, and it's been moved through a distance of 104 meters, and it happened in a time of 3.5 seconds. So I can calculate the power received usefully, and this comes out at 2.94 times 10 to the 6, or megawatts. Right, 2.94 megawatts. That's what's gone in, right? Now, that's 20% of the power that got put in. So I know I could just multiply it by 5, but just to show you kind of how I initially solved this problem, I thought to myself, well, 2.94 times 10 to the 6 was, as a fraction, is a fraction equal to 0.2, right? So if I want to find out what x is, I just need to rearrange for x to find the initial value. So really I'm just doing the efficiency equation here. So dividing by 0.2, making x the subject of this equation, 2.94 times 10 to the 6 divided by, sorry, just tidy this up a bit, divided by 0.2, and when crunching through I get a value of 14.7 times 10 to the 6, or I'll write my answer as 14.7, and it is megawatts. Okay, alright then. So quite a tough one there, quite a lot of thinking needs to be done for that. After reaching its top speed, the driving force is released and it ascends up a steep track. By considering energy transfers, calculate the height the train would reach if there were no energy losses due to friction. Okay, so I think here we are thinking about an energy transformation. Kinetic energy gets converted into gravitational potential energy and there are no losses. So what's the kinetic energy of the, well, what's the formula for kinetic energy first? Half mv squared will be equal to mass times gravity times height, which is the formulas for the respective energies we're talking about. The mass is the same both sides of the equation, so I may as well get rid of that now. Divide both sides by mass. And I want to find the height, so I'm simply dividing by gravity both sides. So I get an equation which is going to be half v squared over g will equal height. So a half, 58 was the velocity that the truck was moving at, or the train, divided by 9.81. Okay, and provided I don't make any mistakes in the calculator, I get the answer 171 meters. Okay, 171 meters. So hopefully you found this useful. If you have any comments, questions, or suggestions, please make a comment. If you liked it, share and comment on the video. Thanks for watching.